Hi, everyone. Welcome back to this data visualization and image processing session. My name is Emmanuel Gouillard. I hope you had a nice break. And the first talk of the session will be given by Thomas Fan from Quantsite Labs about how to light up your data with Streamlit. Thomas, the floor is yours.
Thank you for the introduction. I'm going to share my screen. Okay, and here. All right, so welcome to my talk, Light Up Your Data with Streamlit. I'm Thomas, and all the material for this talk is on GitHub. So let's begin. So what is Streamlit? Streamlit is a Python application that allows you to build web applications and dashboards in Python. So yeah, I know what you're thinking. There's many of these out there, right? So why use Streamlit? And in my case, I want to go through what I think are the three big advantages of using Streamlit. For number one, there's when you're creating a dashboard application, it has the benefits of having regular Python files as source. So which means you get the benefits of regular Python files when you deal with Git and source control. So that's one. Number two is it's compatible with many of the visualization libraries out there, Matplotlib, Plotly. For those who are fans of grammar graphics, it also supports Altair. So it's compatible with many visualization libraries. And lastly, this is one of the key points, is that you can see that there's a radio button here. And to generate these radio buttons, you can see that all I have to do is call st.radio. And it outputs a Python object. So in this way, user interactions are very simple to write because this penguin object is such a string, and in the rest of your program, you could just use it as a string. So I find this very useful and makes it so that's very quick to write these dashboards. So for this talk, I want to cover broadly the Streamlit API, which is a lot, because to be a dashboarding app, you have to cover many things. You have to be able to display text, media, user interactions, visualizations, and also you should be able to lay out your elements on your dashboard. So for this talk, I have many demos, and all my demo material is on GitHub, and and I'm going to use import Streamlit as st as a convention. So let's begin. So text, there's standard things when it comes to dashboarding. You have titles, headers, subheaders. You could write Markdown, math, data frames, and I'm going to showcase this in a demo. So here I have a file that's called demo. I run my command line Streamlit run demo, and I pass in this very specific argument, run on save equal to true, which means that every time I save my file, the HTML rendering will also update. So you can see here, I have titles, and this title will give me a bold title here, and same thing with header. That's everything you may expect from my dashboarding application. So here, you can see that I could change this value to, let's say, SciPy 2032, and you can see that on my HTML web page, it's updated automatically. Let's see. Okay, so that's regular text. Next, there's Markdown. So Markdown, I'm going to copy and paste. You see, I copy and paste this into my demo file, and boom, it automatically updates my dashboard. In this case, you can see that I'm using standard Markdown. And I'm also using backticks for code. You could have double stars for bolding over here. You can have code blocks. So everything you would expect from Markdown. You have LaTeX for fans of writing math over here. And you can also have links and lists. All the Markdown support is here that you may expect. It won't be much of a dashboarding application if you can't handle data frames. So for data frames, I have a very cool snippet here, very quick. You notice that I'm creating a data frame here, and all I have to do is call st.write, and it'll output this data frame. So so sc.write is takes in many different objects, and you would see, and it will understand the object and display it into the dashboard. So that's data frames. So that's media. No, that's text. Next thing you want to display would be media. So media, Streamlit supports the standard media formats. There's images, audio, video, and the API is quite simple. I'm going to showcase some of this for you, with you all. Here you can see that. I'm displaying a lovely picture of this penguin here, and I'm using sc.image, and I'll display this lovely picture of a penguin. I also have audio here, and it's the audio of a penguin. You can see that I'm calling sc.audio here, and also for video, I'm calling sc.video and has this video. So standard, what you expect from a dashboarding app, it supports these media formats. So now this comes down to the big one, user interactions. So for user interactions, I'm going to go back to the slide. You can see that this is all, what you see on the right, on the left, is all it takes to generate the dashboard on the right. What you see is that a user interacts with this widget, this radio widget, and the Python code will update the sequential lines that depend on the output of this widget. So this widget is outputting a penguin object, which is a string. And you can see that everywhere else that uses this penguin over here, like here, for example, here, it automatically updates with the user input. So this is a key API feature about Streamlit. And you will see this in the other interaction widgets that I'm going to look at today. So I'm not going to cover all these. There's a lot. There's a lot of user interaction widgets that you could have. I'm going to cover a selection of them so you get a taste. And let's look at some of them. All right, so widgets. Here, I'm going to copy and paste very easily. I copy and paste, and you see that my dashboard automatically updated. Here's a checkbox. If I click the checkbox, something outputs. You can see on the right-hand side of my Python, you can see that the checkbox outputs a Boolean, and then you could just condition on the Boolean to write out the statement onto the dashboard. So it's very Pythonic in this way. You can just write straight Python to get your interactions. As we see in the radio button, you can see that I could change this to dog, snake, fish, and see that it's the same thing. You have the species here, and it outputs this. You could just write out the species over here. Like using Python, for those who are familiar, I'm using F format or F strings, which are neat features of Python. All right, next, there's and let's say you want to select multiple things and you don't want just one thing. You can select multiple things here. You can see that I have a widget for multi-select. I can select cat, snake, and you can see that the output is not a string anymore. The options here is just a Python list of strings. As you can see that I outputted here. So the API is very simple. It outputs a Python object you could use in the rest of your file. Sliders for numeric values. You have a slider. You can see that it's the same API. Over here, it outputs a value, and then you have the value set over here. So it's very straightforward in this context. Same thing for dates. You could change a date. It outputs, in this case, a datetime object, and you could change it, and also output. Text area, I could write in my name. In this case, for text area, over here, I could use sc.textArea, and I press Command Enter, and it'll give me that. It updates the name in this case, and then I'll put it here. So that's interaction widgets. A very popular widget and very useful widget I want to highlight today is uploading files. So here I'm going to have a widget called File Uploader. It's going to give you this widget. And you can see that I didn't have a file uploaded yet. So what this returns an uploaded file is none. And you could just condition on that in your Python file. And now you can see that there's a do not upload file yet. So one of the ways you can see is drag and drop a file here. So I'm going to drag and drop this lovely penguins data set. And you can see that I just dragged the file here. It notices as a penguin CSV. You can see that I'm writing it out using sc.write, and this outputs this data frame here. So file uploading, very cool. It's very straightforward in this way. For those who notice that there's a 200 megabyte limit, you could change that by changing how you start up the Streamlit session in the command line. So that's user interaction. Let's get next to the next part, which is visualization. So there's not much of a dashboard if you don't visualize your data. So in this case, I'm going to demo some of these: Matplotlib, Plotly, and Altair. They're all supported by Streamlit, and I'm going to show you a quick example of it here. Okay, so here you have my penguins, my lovely penguins data set that we've seen before. It's a fairly simple data set. It has a species of the penguin. It has the island of the penguin, where the island the penguin's located, some physical qualities about the penguin, and the gender of the penguin. So let's make some graphs out of it with different frameworks. The first one uses pandas. You can see that I'm using pandas plot.bar, and I'm going to pass into sc.write the figure object, and sc.write on the matplotlib figure object will give you this output. So yeah, so it's compatible with I'm using pandas backend from matplotlib, and then plotting the matplotlib figure onto the Streamlit dashboard. What's next? I have Seaborn for those who use Seaborn. Same thing. In this case, I'm calling justplot and also passing the fig. Calling .fig in this case because that's how you would access the matplotlib figure in Seaborn, and it'll output this plot. Next, I'm using Plotly Express, which is very cool. And Plotly Express, in this case, px.scatter outputs a figure object, and Streamlit directly understands this and outputs this lovely figure. One thing about Streamlit is that it's interactive. So you see that's interactive. The thing about Plotly is that it's interactive. So this Plotly graph is interactive. Next, grammar graphics, there's Altair. In this case, I'm plotting an Altair chart here, and then Streamlit understands the chart directly, uses passing the Altair chart, and it'll give you this representation. And Altair in this case is also interactive. The thing to know about this is while you're working on these dashboards, you could change things. Let's say I don't like this box plot here. Let's say I want to change that to, let's say, a violin. So I could change this to a violin, and I could save, and you can see that this blocks become the violin plot. So while developing these dashboards, it's very easy to change up your dashboard and have the Streamlit application auto updates to reflect your changes. So that's visualization. So it supports Plotly, Matplotlib, Altair, and it also supports GraphWiz, and there's a few more. So that's my demo on visualization. One thing to note about Matplotlib is that I recommend, outside your Streamlit context, you always use the object-oriented API for Matplotlib. It's very important in this case that you can see that I'm calling sc.write on the figure because Streamlit doesn't work well with the global figure when you use the MATLAB API. So remember to use the object-oriented API when you use Matplotlib. So that's visualization. Next. Layout. So not much of a visual dashboard application. You can't lay out things like your components. So Streamlit has a few options for this. It has a sidebar and something called basic columns, which lays out your components into columns. So I'm going to look at this in the next part. So here I'm going to have a dashboard where I could allow the user to select the penguin's features, and I'm going to output a data frame that's for the selected feature. There's a picture of a penguin here, and also there's I'm using Plotly in this case to plot out the histogram for the feature that the user has specified. So the image, the penguin image is lovely, but I want it next to my my data frame. I don't want to take up this much space. So over here, you can see that I'm writing out the data frame here and I'm writing the image here over here. So I could split these things up by calling sc.beta feed columns on 2. I want 2 columns. And I could use Python context managers to split these things up. You see that my left and right, I save. And now my dashboard automatically updates. And you can see that my data frame is on the left, my penguin's on the right. It looks a little nicer now, right? So what's next is that I have these radio buttons. I don't like it on top. I want to put it on a sidebar. So what I do, instead of calling sc.radio, I could call sc.sidebar.radio. And this automatically puts a sidebar, puts my interactive widget on the sidebar. And you could do this with any of the widgets. You could just type, instead of calling the widget directly, you add in the sidebar and it'll put in the sidebar. The thing about the sidebar is, as you expect, you could close it and open it, and it works as you expect. And you see that my dashboard updates every time I click on something. That's layout, a very quick overview on the layout. What's next? Next, I want to talk about performance. There's a very cool feature, sc.cache, which caches the function return values. So all you have to do to use this is that you decorate a function using sc.cache, and it will, after the first user calls this, interacts with this function and gets a return, Streamlit will cache the value, and all other users that runs this function will also get the cache version. So this is very useful in general for expensive operations, and usually data loading is an expensive operation. So you see that in my more involved demo for my machine learning dashboard. So this machine learning dashboard is quite involved. There's I'm using SHAP values and anchor values, and in this case, the libraries do not have a Streamlit it outputs HTML, but it doesn't have a built-out Streamlit functionality. So in this case, it's a more real-life example where I need to have more glue code to plug things into each other to build this dashboard. And I'll share this dashboard. So I'll share this dashboard with everyone at the end of the talk. It's hosted up online. So let me look at this dashboard here. I will show you what the dashboard looks like. So this is the dashboard. You can see that I could change. In this case, my dashboard is going to explain a prediction where I have a machine learning model that explains that predicts the species of my penguin based on based on features of penguin that the user has provided. So you can see that I could change the features of this penguin. It'll give me a prediction, and it will also output the SHAP values and anchors. So I'm going to briefly go over what this looks like in code. So you could see what it looks like to have a more involved example. So let's look at this here. So you see I'm pasting it in, and it automatically updates. Just to quickly go over this, you see internally I have a scikit-learn model. It's just a column transform over a random forest, and I pickled this so that I serialize the model. And one thing to note is that you could call sklearn.setconfig display go diagram, and you get this lovely diagram here when you're working in Jupyter notebooks. So I have a pickled scikit-learn model in this dashboard. So I'm going to go through some key points here. You can see that I'm using sc.cache to load data. Usually this is an expensive operation. In this case, it's a very small data set. It's not that expensive. But in general, loading data is very expensive. Here, you can see that I have these radio buttons. There's these radio widgets on the sidebar that gets these configured to your dashboard to have these widgets. Next thing to note, I'm loading the model and predicting over here. So here I want to look at the SHAP values. In this case, the SHAP library doesn't interact with scikit-learn's pipelines that well. So in this case, I have to kind of use Python to wrangle the scikit-learn pipeline a little bit. And the key thing to note here is that for those who are familiar with SHAP in Jupyter notebooks, it outputs the HTML by using repr.html, repr_repr.html over here. And then in my Streamlit app, I call it directly, and I push them all together, and then I call components.html, which creates an iframe to put all this HTML into to output this dashboard over here. So that's why you need, when a library doesn't directly support it, you have to do a little more work to get this to work. Same thing for anchors. Anchors, I'm using sc.cache because it's on this anchor explainer object, because it does some non-trivial computation. And I also have to write a little more glue code here to get it to work with scikit-learn's API a little bit. The thing to know here is that you can see that I'm calling experiment as HTML, and this will output this anchor. This will give me an HTML representation of the explain instance object, which gives me this this HTML representation for Streamlit. So that's a very quick overview of this dashboard. The high-level overview is that if your library doesn't has HTML output but doesn't support Streamlit directly, you could create it by calling components.html. It'll create an iframe embedded on the object. So that's components that don't support Streamlit directly. Turns out there's Streamlit components where there's libraries that build extensions for Streamlit. There's a gallery for this, and I'm going to showcase you some of them here as well. So I'm going to showcase Folium and HiPlat. So these are two components where these are community-built components so that it interacts with Streamlit directly. So I'm going to show you first Folium here. Folium here. So Folium, I'll split my screen up again. So Folium, for those who are familiar, you could easily create a map. And in this case, this is where SciPy 2019 was in Austin, Texas, right here in this convention center. And you can see that there's a library, Streamlit_Folium, import Folium static. And in this case, Folium_static outputs this this Folium map object here. So you don't have to write all this glue code anymore. So your community members have built Streamlit components to interact with, to directly interact with, connect libraries to Streamlit. Another cool one is something called HiPlat. So those who are into machine learning and hyperparameter search, this is a fairly cool one. Because I'm using sc.cache to cache expansive operations. And in this case, HiPlat directly builds a Streamlit component, and I could use this here to visualize this hyperparameter search. In this case, there's many things to say about this visualization. One thing you could do is like choose the best test scores, and then maybe you want to choose the best mean score time, which means these are the fastest models when it comes to prediction. And then, you can see these hyperparameters that give you the best scores and also the best prediction time. So it's a very lovely visualization. So that's two components for Streamlit that's developed by the community. There's many more to explore. There's a whole gallery. So yeah, there's a whole gallery. I didn't go through all of Streamlit's API, but there's the session state API. There's also forms. There's also custom themes. And so there's more to this API. There's also Streamlit.io/sharing, which I recommend once you get an invite, they automatically host your application as long as you put it on GitHub. So this is very nice. Also, there's a gallery, Streamlit.io/gallery, which has a gallery of what the community members have built. We're using Streamlit, and you can explore these. There's many different categories that you can see over here. Next, there's also Streamlit's on GitHub. They also have a discourse. You can follow them there. And to end this talk, I want to go back to the three advantages I feel are great about Streamlit. Is that you can see that my source files are all Python. It's compatible with visualization libraries, and user interactions are simple to write. So thank you for coming to talk. My name is Thomas. You can find me on Twitter, on GitHub at ThomasJBFan. And all the materials for this talk, the slides, and my demos is also on GitHub.
Thank you very much, Thomas, for a very exciting talk. We have 5 minutes left for questions. And so you have a lot of questions actually in the Q&A tab. Do you want me to read them, or would you rather read them and answer them?
Okay. Wow. All right. I could read them and answer
Okay,
them.
you can sort them by upvote to start with the most upvoted ones.
All right. Let me. Okay. Cool. I'll read the question and answer the question.
Thank you.
All right. Is there any relationship between Streamlit components and Jupyter widget ecosystem? Can we reuse Jupyter widgets? There isn't a relationship. So this is, there's no good direct connection between Jupyter notebooks and Streamlit components. So they're separate. So you can't reuse them. Next.
You should sort them by upvotes to start
okay.
with the most you have sort.
Okay. All right. So there's a more highly upvoted one.
Yes.
All right. Is it possible to capture plot interaction events, plot section, and use this information elsewhere in the app? In this case, so there's a few ways to do it, but if you need to capture something from the plot itself, so you could feed in user information into the plot, but to get the information out of the plot, I don't think it's currently possible. Unless there are libraries, there are components that built this into the component, so you could grab information out of the plot. So like something like the high plot example I showed, there's a way to get out information from that plot, but the component developer has to build this into it. So there is a way to do this, but it's not built for everyone, for all the components. How does this interact with HoloWiz? I do not know. Next question. Things are getting upvoted sometimes, and it jumps the slot during a second. Does the Python module get re-executed with each user interaction? Yeah. Yes, it does. How can one create different tabs for the dashboard? There's a few ways to do this. They're all kind of hacky, so I don't think it's officially supported, but there's a ways to control. Like you see how I could have rated buttons change the output of my dashboard using like a if statement. You could do that for the whole page, and you can have like tabs control the output of your dashboard. So you could use a widget to control this, but it doesn't feel that supported right now currently. Next, is the layout responsive? Yes. So yes, the layout is responsive. Let's see. Next, how can one? Oh wait, no. Does this have a serving component? Yes. So it requires Python to be running in the background. What is that view that you are showing rendered as? Is that in a browser? Yes, that's also in a browser. It's connected to localhost at a port. Okay. Next, how did you spin up the app on the right? So you have 2 more minutes. Okay, good. All right. So how do you spin up the application on the right? After you installed Streamlit, I called Streamlit run demo.py, and then you can see that there's a URL that I can open. And this URL points to what I have to put in here to get to this destination.
And speaking of this, how can you deploy to a distant server, for example, like deploying apps? Do you have any comments about deployments of Streamlit apps?
Oh, so first, like I reiterate, you could use Streamlit and they'll host it for you for free. So you put it on GitHub, they run the Python process, and it works that way. If you want to deploy it yourself, it's the same as most other deployments. When you have a Python process, as you can see here, that internally it's a local host at 8501. What you have to do would be to expose this online. there's many methods to this. So that's for deployment. But at first, for newcomers, I recommend using Streamlit sharing because it handles it all for you. You just put on GitHub and they'll just host it for you.
So I'm really sorry, but I think we're out of time. There were a few questions left, like have you tried to host a Streamlit app in AWS? Or maybe you can reach out to Thomas after the session on the chat. But yeah, let's give a round of virtual applause to Thomas. It was a great talk. Thank you so much. And we'll be back in 5 minutes with the next talk. So we'll connect. We can end the session now and we'll connect back in 5 minutes. Thank you.